Good morning and welcome to the ZP Developer Zone. So we do these webinars sometimes twice a week, sometimes once a week, but today is Sunday the 18th of February and we're going to do a quick answers to some technical questions that have come in during the week. So let me essentially dive into it. At ZP we're all about, I describe it here in this title as sort of sensor to API, sensor to application program interface. So we have a whole stack of technologies from sort of screen printed electrodes to electronics, to wire sensors, to a cloud, and actually all of this will get covered today as well. And all these technologies are designed really to get people onto the market. There's really a sort of massive amount of research going in the world, especially in the world of electrochemical biosensors, and not enough of it's getting onto the market. So it's not really giving society a return on investment. And I think in part that's what ZP is about. So we say from field to cloud. So what by that we can put sensors in the environment and we can get the data up to the cloud. We can put sensors on or in or near people and get the data up to the cloud. So we sort of describe ourselves, from field to cloud to from person to cloud. Now, if you watch this entire webinar, you will actually see that all these aspects are definitely covered. Our business model is contract development, contract manufacturing. So you will hear me use the term OEM. I realize at some point I want to grab some hardware, so you might see me slightly jump out of frame at one point and actually grab some hardware. We are having, just as a way of background, we are having a webinar on the 27th of February. Please come to one of them because they are a live streaming webinar and they will in live, obviously in real time, show you how we are recording. Well, we're making a measurement on an instrument and we're sending the data up to the cloud. So please come to, and it just demonstrates the robustness of the technology. So definitely introduction to ZP, but definitely live streaming demo of this entire kind of technology stack. The one in the morning is for people in sort of Asia and Europe, and the one in the afternoon is for people in Europe and the USA and Canada and South America, etc. So choose one that matches your time zone the best. If you see a link jumping up at the moment, don't worry, I'll put the link underneath the YouTube video and you can sort of find the relevant information. For example, we do corporate workshops. So for example, I did do a corporate workshop at the end of last year where I went to the US and we did a workshop on wearable and CGMs, continuous glucose monitoring. We did the workshop live at their site because they were able to raise about 20 people. It did make economic sense for them to have me there. And everyone made a sensor, everyone tested a sensor, so it was very successful. So it's just worth saying that if you've got less people who are interested, for example, in IVDs, in vitro diagnostics or biosensors, we do actually hold workshops at our site as well. There's one in March, there's one in April, there's one in April, March, June, there's one in June. So we do them every month. If you can't find one, don't worry, just contact me or contact us. There's a contact us at the end of the webinar or underneath the video, and you'll be able to find us and ask us when the workshops are. So if you're interested in our technology, come to the free webinar on the 27th of February. If you're interested in having ZP come on site and work with your team and demonstrate to your team, then we also do those workshops. Or if you've got less people, come to one of our workshops. It's not really called out here, but actually, most of ZP's work, and well, good 50% of it actually comes from doing contract development, contract manufacturing with people, but that's not really called out today. As I say, the philosophy at ZP is we know that there's plenty of people in this world who can benefit from electrochemical biosensors. It could be environmentalists, it could be farmers, it could be clinicians, it could be patients. And there are people who want to provide solutions to them. And for ZP, we try to put all the hardware in place, that as much as the technology in place, so that people actually can act quickly and get market share. I think there's too much delay in people kind of having an idea, then they go off and kind of invent all this technology. But realistically, most of this technology exists. It's just, I think I would rather integrate this technology together and get first mover advantage rather than spending, it can be up to 15 years people do this kind of stuff and then actually are not successful at the end of it. So I'd rather take the technology that exists, integrate it, start getting technology into the hands of these people and start getting feedback So the whole philosophy of ZP is there are people who need technologies, there are people who want to provide technologies, there are people like ZP who sit between them who probably have some of the technologies, and it's really a kind of take the technologies we have, start putting them in the hands of real users, and because we have everything is cloud connected, you can start gathering data really early on and actually start making sure that the data coming from these users is actually of good enough quality and good enough for the sort of final sale, let's say. And it's because everything is cloud enabled that it allows this virtuous circle of you shipping, people testing, you seeing the data, you potentially improving hardware, that's the mechanical, the electronics, the algorithms, the sensors. So we're all about getting stuff out to people very quickly and getting feedback. This is really a kind of part of a lean startup mentality, I would definitely say. So questions today. Somebody was asking about our Platinum 501 SPE. What's the voltage range on them? Somebody else was asking for some data so they could do this Randles Sevcik equation, which I'll talk about. Somebody else was asking about custom screen printed electrodes, which I'll talk about and go through. And somebody else was talking about GOX activity on a CGM, which I will cover as well. So question number 1 is about the 501 Platinum. So even if you're looking at custom screen printed electrodes, or you're looking to make CGMs, continuous glucose monitoring, some of this is pertinent to you. So ZP, we do have a whole, I don't want to say bunch of screen printed electrodes. I think these are the best quality in terms of repeatability sensors on the market, and I'll make those statements during this. So we've got some carbons, we've got some platinums, we've got some carbons, we've got some platinums, and we've got some gold. So we have these various screen printed electrodes, and the person's particularly interested in the 501. If you're interested in these screen printed electrodes, just as a side note, if anyone is developing an IVD, an in vitro diagnostic, if you can go for carbon rather than platinum, you're doing yourself a really big favor. Platinum and gold is just so astronomically expensive these days. We buy these little pots of, let's say, platinum and gold paste. We actually formulate them together. But when you by the time you've got the gold and you put it in there, or the platinum you put it in there, it's so expensive. It's absolutely terrible. So it actually, I think, at ZP, sure, we use platinum, gold, and carbon. But whenever we've got the choice, we always go for carbon. And people sometimes think, oh, I've got to use gold because I'm doing a self-assemble monolayer. Or I've got to use platinum because I'm making a hydrogen peroxide-based sensor. You can engineer yourselves around these limitations. I mean, if you're not sure, talk to ZP. But if you can, always go for carbon. Anyway, to the point, we do have all these screen printed electrodes. I think they're really good. This person was asking what's the kind of voltage range that they can use these screen printed electrodes on. When we're testing them in-house, this is a cyclovoltammetry of ferricyanide. We do a lot of testing of these electrodes before they actually leave and go off to our clients. And so we actually test them between minus 0.2 and 0.5 volts. I haven't exhaustively looked through my website, but I would imagine through our database rather. This is the Julie database I'm referring to, which will come up in a bit. I haven't exhaustively looked through it, but I imagine that you could probably run this between minus 0.9 and 0.9 and you'd be fine. If you go down to minus 0.9, you see it here as well. This wave here is due to oxygen reduction. So there will be a sort of, if you're in aqueous solutions, expect to see the oxygen reduction down in the kind of negative potential or cathodic potential regions. And then mostly, unless you've got your active material in there, it's quite flat up in the oxidation region until it hits the hydrolysis. The hydrolysis starts to kick in round about 0.8 volts. So the quick answer is this is how we standardly test them. I imagine those electrodes are fine between minus 0.9 and 0.9 volts. If you've got any problems, record the CV and let me see. In terms of equipment, we obviously do our EIS, we do potentiostats, we do connectors, also this is cabling, we do connectors, I want to say etc. So that will support those screen printed electrodes. Question number 2 is about the Randles Sevcik equation. I just want to doing a quick check of something offline. Yeah, not offline, but on the side here. So I have just checked that. So we have a really, really one of the most mature technologies stacks that we have, or technologies that we have, is actually our Julie database. It's pretty powerful. People have watched videos, or somebody has watched a video where actually we were looking at cyclic voltammetry versus scan rate. This is often characterized by something called the Randles-Sevcik equation. And I will discuss that shortly, but I'll put a link to that video if you're so interested. This happens a lot in scientific or electrochemistry or electroanalytical papers. People always do this, and I ask a question here: what is the most common way of analyzing cyclic voltammetry? I should say analyzing screw-fed electrodes or assays, but people do this experiment all the time where they'll take a electrochemically active molecule and they will look. This is the Randles-Sevcik equation, and the Randles-Sevcik equation says to you that current is proportional to the square root of scan rate, and they'll change scan rate, and then they'll show that their peak current is increasing according to the square root of scan rate in a linear fashion. And this kind of tells you that your redox reaction is probably reversible, and it tells you that it's probably under diffusion control. So it sort of tells you something. But I actually think the value is really limited, actually. I mean, at least in making biosensors and electrochemical assays, it's interesting. But why do people do it? They do it really because it looks nice and it's, it's easy to do, and you can publish with it. So it sort of ticks a box for publishing. At ZP we rarely do this experiment because it really doesn't add a lot of value to us, because we're laser focused on electrochemical biosensor development. But people do it. I mean, I did it in my PhD myself, but I look back at it, I think I can see now, I was just jumping through some hoops, really. But people are interested in it. We have videos about it. We also have some data in it where we were actually able to demonstrate. The nice thing about Julie is really the only world's only data management system specifically for electrochemical data. I'll put a link to it in a minute. So if you're working with ZP, then all the data we gather in the lab goes up to Julie. Clients really like it, but obviously because it gives you a really good transparency about what's going on. And it saves a lot of time because it's so automated. So, we upload the data, we label the data, we have tools for manipulating the data, and then we can actually graph and visualize the data. So the outcome is we can take data like this, we can use Julie to actually do what we call peak finding, and then we can plot current versus the square root of scan rate, and we get a really good fit because, the Randles-Sevcik equation is quite a robust way of analysis. I want to say it always works. It works in the context of if you've got a fairly well-behaving electrode and your redox molecule is in solution, it is under diffusion control, and it is fairly reversible, then the Randles-Sevcik equation sort of works a lot. What I want to do is a quick demonstration. So what I'm going to do is I'm just going to drag this screen in slightly and just say to you, if you want this data and you want to do what I'm doing, I will give you access, and I'll discuss giving you access in a minute. So first of all, let me have a look down here. Yeah, all right. So what I'm going to do is I'm just going to turn off some things. So Julie, super, this has been 10 years in development, a super powerful, I want to say system, but system is a sort of it's a data management system that all this data that I'm looking at at the moment is actually up in the cloud. When we're in the lab, we gather our data, and then it's immediately uploaded to the cloud. So what I have here is I have a series of voltammograms collected at different scan rates. I've actually uploaded that data, so I can essentially see it here. And what I've done is the data resides, and I will tell you how to access this data as well. The data is up in the cloud. I have an ID, I have a curve title, And I've also labeled this. I went in here and made sure that that was 10. So I had, because I saw that this was 10 millivolts, I put 10 millivolts in here. I saw that was 25 millivolts, so I put 25 here. I saw that was 50, so I put 50 in here. I saw that was 100, so I put 100 in here. I saw that was 150, so I put 150 there. 200, 200, 500, 500. That's fine. Right. And then under properties now, I know that this this data is what we call, it's a terrible name, but it's a discrete data. And so it's a one-off experiment. In a minute in this webinar, somebody's going to be asking about continuous glucose monitoring, CGM. That's continuous data, but this is discrete data. So it's discrete data, and I'm really interested in the scan rate, so I put the word scan rate in here, and the units are millivolts per second. Yeah, that's correct. And I just check now my voltammetry discrete that I want to analyze it. And so I'm going to show extracted values, and I'm going to go and find the peak height. Now the peak was approximately 0.25 volts, and it was at, and I'm going to put a window in here of 0.1 volts. So I look at 0.25 volts and give it a window either side. And I'm going to leave it at that for now, and I'm just going to close it and just let the database, I want to say do its thing, but the database is doing a quick calculation. So what it's done now is it's opened a window here, and it's centered on 0.25, and it's given itself a window of 100 millivolts in total. So that's basically 0.25 volts plus or minus 50 millivolts. But what's nice to see is I didn't have to drag my cursor around trying to find these peak heights. The software just immediately did it. And it's also tried to plot the current versus scan rate. Now at the moment it's using a linear one. So what's happened is my original values are actually not following the linear. They're actually showing a curve like this. But I'm just going to go back in, and I knew I deliberately left that in there. So I'm going to fit the formula to a square root, and then I'll close that. And now what it does is there's an absolutely perfect fit, because, you know, the Randles plotting a redox mediator on a well fabricated screen printed electrode and changing scan rate, yeah, you will get a good signal or good current versus square root of scan rate every time. Let's say, you know, I don't want to overplay that, but it is such a sort of almost like a trope, you know, of an experiment that, you know, it's quite easy to do. I'll save that now. It's just saying incomplete because I haven't filled in all the details, but it doesn't matter for this. And I just want to demonstrate that there's a real power to ZP, to Julie as well. And the power is that, you know, everyone should be working in teams these days. You know, and teams don't have to be necessarily in the same lab as each other, because the person who wants this data now, once they've joined Julie, I will be able to, whoops a daisy, I'm going to have to go back slightly. So I'm going to find that, what I call a cluster, which is here. I can share it with them. So they need to join Julie. So Julie is, you can just get a freemium account, at which point then I can add you, your email here. And then when I go done, it will actually invite you to get the data and see the data. So the quick answer to your question is, if you're interested in playing with Julie and you're interested in playing with this set of data in order to sort of analyze Randles Sevcik and analyze the features of Julie, you have to join Julie, and I'll go back to my presentation actually. So I did a quick demo. Here's a contact us button. So I showed you that actually we have the data up there. I've got it in a cluster. I can share that cluster with you by clicking the button here, but first of all you need to join Julie. So first of all join Julie, and when you've done that, then we can share the data with you. The reason being is I'm really hate is a strong word, but I don't want to send data around the world. You know, we live in a modern cloud connected world. You know, and you know, it's convenient to email stuff, but when you're emailing, you're kind of losing. Before you know it, you're talking about several different bits of data, different variations. It's nothing like having everything organized in the cloud. So join Julie, and then we can share the data with you. Question number 3 is about custom screen printed electrodes. So I've realized I've talked for quite some time now, so I will go a little bit faster, let's say. We do have a lot of very good screen printed electrodes. The thing that makes these screen printed electrodes good is, I think, is the fundamental quality of them. So, you know, you could do things like the Randles Sevcik equation on there or analysis and it'll work fine. Our peak-to-peak separation, we've really worked on making sure that we don't have high resistances. We used our screen printed electrodes a lot. We use them. It's a really big difference. So many people are producing screen printed electrodes and are absolutely not using them. So if there's anything wrong with a batch of screen printed electrodes, you will never know about it because we'll know about it and we wouldn't have ever shipped it. Now, if you come to our webinars, there's one on the 27th of February. Please come, because what you're going to see is we'll do these really strong demonstrations of the power of the ZP platform. The word platform should come back in later on because people ask about custom screen printed electrodes and they're kind of decouple the screen printed electrode from the entire system. At ZP, we have a holistic approach. But my point here is you will see no calibration, and that's because the underlying screen printed electrodes are so reproducible. I should use the word here, repeatable. I'm really trying to, it sounds ridiculous coming from a guy with a fairly strong analytical sciences background these days. And you could, you know, still struggling with the word reproducible versus repeatable, but that's a side comment. At ZP, you won't see bad screen printed electrodes coming from us. Why? Because we actually do what we call wafer mapping. One of the guys who's kind of asking this question slightly is a really senior electronics guy, so he knows about wafer mapping. In many industries, when you make components, you actually test those components. This is not overly done in the world of screen printed electrodes, especially screen printers who are not really, you know, they're really printing touch screens, they're printing decals for cars and stuff like that, or they're even printing print, you know, readable print. They're not really doing this kind of characterization of materials before they're shipped, but we make sure that we characterize it before it's shipped so that we can understand the peak height through a batch. So here I can see 5.8 peak heights on those voltammograms on sheet 102. On sheet 103 I can see the peak height is about 5.99, if I can call it that. I can see the peak heights. And what we're looking for is to make sure that our relative standard deviations are kind of in single digit. Bit of a rule of thumb that if your final assay can have a relative standard deviation within 20%, then it's not a bad assay. I know it can depend on the application, but here we're showing that we can. You want your underlying electrodes to have a good repeatability, which is something that we've really worked upon, and we characterize it and we do it before we actually ship. So when you look at these are different concentrations done in triplicate, and they're really tight. Every triplicate is really, some of them are overlaying, and at least the third one is pretty close, and that's the underlying screen printed electrode for you. The problem with custom screen printed electrodes is actually many people sort of make their designs far too big. So people come to us, they say, here's my design, I think it's too big, it's never going to be commercially viable. So we need to really advise people. I just want to say good morning to Ali. Thanks, Ali, for joining this morning. It's always lovely to see you. So the problem number 1 is screen printed electrodes are often too big to be commercially viable. Problem number 2, people don't design screen printed electrodes with microfluidics in mind. You've got to ask yourself the question, how am I going to bring the sample to the sensor? Question number 3, people are bringing the wrong geometry. Question number 4 is quality. People are just not. If to make a quality screen printed electrode, you actually need to be making it quite regularly, and people are just if you go for customization, the quality can suffer because you're not producing it in high volume. People treat screen printed electrodes like they're going to be really low cost, and they will get them at low cost, but actually get them at low quality. You really should think that in the early days, trying to make a quality screen printed electrode is actually going to cost a bit. And because people are viewing screen printed electrodes as components in an isolation of the system. So at ZP, we will not view your screen printed electrode in isolation of the entire system. But of course, this kind of attention does actually cost money. And number 7 is about sample size, that we design our screen printed electrodes for sample size. Just give me 1 second. I'm just going to run for 1 second. Thank you. My apologies for that, but I will just jump straight back into it now. I realize I've stopped sharing my screen, and there we go. So people have many problems. I think there's a lot of problems with custom screw-printed electrodes, and I really need people to understand that you can't treat these like a how do I put this? You can't treat it like, oh, I'm just going to go to this manufacturer and they're just going to make me some screw-printed electrodes. Everything's going to be perfect. It's really a program with the manufacturer. It's not just sending the design, because if you send in a design, you'll get something back from that person. But then I've seen people do this. They've gone around, they've shopped for the lowest cost screen-printed electrode. They got it, and then in the end, they found that actually the usable yield from that screen-printed electrode was 1/3, which is kind of ironic. And then they came to the ZP, for example, and they got the cost for low volume, high quality from us, and I was actually 3 times more expensive, so they didn't go with us. But of course, what I was trying to do is guarantee that most of those pieces, like, you know, close to 100%, were very usable. Whereas they went for the lower cost people and actually found out that only 1/3 of them were usable, but they were paying for them. But they spent a lot of time then having to filter or do incoming materials inspection to actually use the good electrodes. So it's a really false economy. So we at ZP can't enter into the game of, you know, this vendor does it for this, that vendor does it for this. If you're interested in just the cost, then you should go with the low cost vendor. If you're interested in getting to market and actually having a robust product, I hope you would consider ZP, but we would treat it more like a program, rather than treating it like a sort of, you know, one-off batch manufacturing. And there's a lack of vendor understanding, I think. So when things go wrong, or, you know, when ZP's on a program with you, and it may be the program has a specific point about making a screen-printed electrode, I think we're doing it from a perspective of understanding the fundamental science of this. Question number 4 is about activity of GOX in CGM, continuous glucose sensors. It's interesting actually, because Ali's talked about this in some of our conferences about wearable sensors. So at ZP we have many configurations for wearable sensors. I think the ones that are most advanced with us are our wire filaments. Our microneedles are extremely advanced. I might have to grab a microneedle system now, actually. Let me just do that. Yep, I've got a couple of examples of microneedles here, so I'll show those in a minute. And we do wearable sensors. I wouldn't be doing glucose in the sweat. There is a company in the US that's doing this. It's novel, it's painless, but it will also be quite challenging in terms of clinically proving this. It could even be a 20-year journey, you know, but they'll have to go after wellness in the first instance, rather than obviously necessarily controlling type 1 and type 2 diabetics, but I'm sure they've got that really in their business plan. And we also work on implanted sensors as well. I will comment on that in a minute. What do all these sensors? At ZP, we've done wearable ketones, wearable lactates, wearable glucose, a whole host of wearable potassiums. But if we talk about glucose, then they all have a glucose enzyme at the heart of it, and the person wants to know about the activity. I think the sensors that are the configurations that are best for CGM, continuous glucose monitoring, are actually the microneedles, the implanted, and the wires. The wires are the most mature in terms of, there's more products on the market using this kind of wire configuration, at least in the CGM space. This is the package that we have. I mean, this is really millions of dollars have gone into this kind of package. This is one of our packages. Don't think this is the only thing we've got, but this is a little package which we can deliver in a glucose sensor, and it has all the electronics associated with it. This is not my product. This is the Abbott Freestyle Libre 2 for scale. I mean, I think it was probably on this arm here. Is that right? No, it's probably here actually. Left arm. That said, that's the sensor. But if you're interested in doing those kind of sensors, then we do have the technology to do that. We're primarily working with this kind of technology actually in, sounds crazy, but in fish. This fish is not dead. It's anesthetized. These are called sutures. They're literally going to stitch it back together. So we drop the fish into the cavity. Sorry, we drop the sensor package into the cavity of the fish, and it continually monitors. I just want to say to Ali, who's online today, there's a webinar on the 27th of February, Ali. I think it would be super interesting to you. If you could come, that would be great. I'll put a link underneath the video afterwards. Anyway, put the sensor package in the fish swim around, and we continually stream the glucose data from the fish. The reason I rushed off there for a second ago is because I realized I wanted to get hold of this. This is the CGM technology, sports version, and then sort of more, I don't want to say medical, but these hardware are actually using, I've got some here. On the back of these watches, there's a insert. The insert has microneedles on it. The microneedles penetrate the skin. You can appreciate that when you put one of these watches on, what's happening is the strap is pulling the microneedles, into the skin and monitoring glucose. What's worth saying here is that ZP actually holds a patent portfolio of 50 patents on this. So if people are interested in partnering around microneedles, we have a really good freedom to operate because we actually have something like 50 patents behind this. So we are looking for partners on CGM, particularly on the microneedle technology. Microneedle technology is it's painless. It offers multiple analyte opportunities. So not just glucose, but glucose plus ketone. And for me, you are going to have to do something a little bit special or different in the in the CGM space, because there are some there's these incumbent large players. If you just come in with a better mousetrap, unless you come in with a better mousetrap that's a lot less cost, that can be an advantage. But I think microneedles, the fact that there's quite a lot of real estate, so this is the insert, there's quite a lot of real estate on these kind of microneedles, so it allows you to do, as I say, glucose plus ketones and not have to have multiple sensors stuck in people. They can do it all off the one particular platform. Obviously, anyone who comes to one of our corporate workshops, who comes to one of our actual workshops, actually gets to build their own glucose sensors. Probably worth just saying. The reactions that are running here is the glucose reacting with the glucose oxidase, the oxygen forms hydrogen peroxide, and if it's a generation 1 sensor, then we're detecting the hydrogen peroxide. And that's something that we routinely do in our lab. Anyone who comes to our workshop ends up doing this experiment, and the person's interested in the activity of glucose oxidase. Now, what we do in order to ensure that we've got enough activity of glucose oxidase is we do these experiments where we'll put the glucose into the solution, we'll add a stock solution, we'll bring the glucose to 5 millimolar, we'll add some more, we'll bring it to 10 millimolar, we'll add some more, we'll bring it to 15 millimolar, and we add some more and we bring it to 20 millimolar. By the way, you can only do this experiment if you've immobilized your glucose oxidase on that surface. So that's something, it's a small detail, but just FYI, the experiment won't work unless you've immobilized the glucose oxidase. So what we're looking for is we're looking for a good linearity up to 20 millimolar. If you do not have enough activity of glucose oxidase, you will lose signal. In the worst case, you'll lose it probably between 5 and 10, between that then 10 and 15. But here you can see we've got good signal up to 20. And why is that? Because we have a good activity of glucose oxidase versus the glucose concentration and the oxygen concentration. So we have done a good job in designing all of our materials to get that to place. I suppose that's part of the answer as well. It's not enough to think about the glucose oxidase activity. You've also got to think about the oxygen flux as well. You could be going for a Gen 2, which you could argue is oxygen independent. Don't think about Gen 3. I know what Gen 3 is. I would consult into you and advise you not against going to Gen 3. Because these people are interested in CGM, we do also have the electronics to do this kind of work. If you see a link, I'll put the link underneath the video. We also cover this in workshops. We come on site. What I want to say is if people are interested in understanding or formulating glucose sensors, including the activity of glucose oxidase, then ZP can be engaged. We're ISO 13485, and our certificate says for the contract development, contract manufacturing of including biosensors. So contract with us and we'll help first of all understand where your technology's at, and then help to bring your technology to the right place. It's quite quick for us because we've been doing this. I've been doing glucose sensing for approximately 23 years, and I've been doing CGM, continuous glucose monitoring, for about 15 years. And I happen to have quite a deep knowledge in at least the core science of it, because I am a PhD by training, or a PhD electrochemist by training. But it wasn't the PhD in electrochemistry that taught me this. It was industrial experience that's really taught me. So question number 1 was about Platinum 501. I think you should try out that electrode between minus 0.9 and 0.9. You should be fine. That's voltage. The Randles-Sevcik equation, I've put the data up into Julie. Get yourself a Julie account. When you've got it, let me know and I will invite you. Question number 3, screen printed electrodes. Be super careful about custom screen printed electrodes. They're never the quality you want because everyone's treating them like a commodity item. I think you need to engage with people like ZP, but treat it more like a long-term program than a short-term screen printing run. And then on your GOX activity, the question's not just about GOX activity. It's actually about oxygen flux, glucose flux, the polymers that you're intending to use, and also the application space that you're intending to do. Is this in vitro, ex vivo? Well, I know, sorry, in vivo. I can understand. Is it in vivo, or what it was sometimes called ex vivo? Some people try to do it on the skin. Is it microneedles? There's too many questions, and I think it really requires a program between us, a paid program, in order for the ZP to really answer that. If you've got any questions, please don't hesitate to reach out to us. I want to say thank you to Ali for being patient and this morning. Ali, there's a webinar on the 27th of February. I really hope that you can come. The technology stack has got really good. We're also starting to work, Ali, on measuring water sanitization. So keep watching the space for water sanitization. Okay, thanks so much. Take care. Bye-bye.